Hello YouTube, and thank you for watching. Today I want to share a recent experience I had troubleshooting slowness with a package that was in production. The package was written by an outside vendor. It was rather verbose and very lengthy. And there were procedures that were calling other procedures that were calling other procedures. So following the execution path was rather difficult. So what I'm going to do in this session is show you a very simplified example of how to profile a package using Oracle SQL Developer to show how this tool can be used to profile simple packages. And then the second session will be explaining how it's done in the real world with packages that are very lengthy and complex. So let's get started. So this session is titled How to Identify Bottlenecks Quickly and Easily in PL/SQL Packages and Procedures. So what I'm going to do is first execute this procedure. And what it's doing is this retrieve pad report is the main procedure, which is calling other procedures. And here we are. The procedure took about 14 seconds to complete, and this is rather slow. So what we're going to do is try and identify the bottleneck, and we do that by right-clicking on the package called the slow package, and in the pop-up menu you'll see a menu called profile. So this is the main method, which is invoking the other procedures. So let's go ahead and profile the session. In the comment you can put a name of this session. So I'm going to label this and we'll execute it. Now what what this Oracle developer is doing, it's executing. Unfortunately, there's no progress bar or hourglass to indicate its execution, so you just have to be patient and wait until the execution is completed. One flaw here is that it doesn't update the list automatically, so you have to click on this refresh button. And here is profile number 4. Let's go ahead and click on this. So what it shows is the execution steps with the function names here. The column that you're interested in is percentage right here. Here, function percent. And here you can kind of follow along and see that 100% of the execution time was actually on this particular select statement. These are essentially call stacks, and you can see that the first method that was invoked was here. And from this execution list, it's not really obvious what method is calling in the order of execution. So as the package complexity increases, this becomes rather difficult to detangle. Okay, let's go ahead and look at the package body. And the package consists of 4 procedures. We have 1, 2, 3, and 4. Okay, and let's go ahead and look at the package body. And what you'll see here is that the retrieve pad report calls 2 procedures. The first one is called create hist entry, and the second one is called create reg entry. So if we go to the first procedure, create hist entry here, you'll see that this procedure is calling a procedure called retrieve common. So if you trace that step, you can see here that here is the select query that is consuming the execution time. Once this is completed, now it's calling the second procedure, the create rec entry. So the create rec entry is again calling the retrieve common, and retrieve common is again running the select statement. So in this simplified example, it's rather simple to follow the execution path and visually identify where the bottleneck is occurring. In the real world, it's never this simple, and most of the times the procedure will contain hundreds of lines of code with multiple select statements. So I find this profile method very limited in the real world. For very simple packages and procedures, sure, it can be used, but not for real world workloads. Okay, so now that we're done with the simplified example, the package that I had to profile produced a list that was rather very difficult to untangle, and it did not identify the query in question. So how do you deal with it? Well, you go back to the old method of using print statements. So if you look at the code here, we're invoking this main method, okay? And what we can do is sprinkle some timers in here to help us identify where the slowness is occurring. Visually looking at the code, actually you shouldn't be looking at it visually to begin with. What you're looking for is a generalized method to help you identify the area of slowness to focus on. And the way to do that, as I said, is to sprinkle timers and use print statements. Okay, this right here, okay, is called the util call stack concatenate subprogram, and what it does is it prints the current package name and the procedure name. So what I've done is essentially invoke this as the procedure begins, indicated by the begin statement, and when the procedure ends, indicated by the end statement. So I've added the two lines at the start and the end to every procedure. So as the package executes and procedures call each other, we can have a list with timers to give us an idea where the slowness is occurring. Okay, let's go ahead and execute this. So what we're going to do is put the server output on size unlimited, set timing on, and then invoke this procedure again. Okay, so here we are. The PL SQL procedure has completed in about 13.5 seconds. And these are the steps that were taken as the package was getting executed. Here you can see that we start with create hist entry, which calls the retrieve common, and it ends, and then it finishes the create hist entry that was started here. And the next one is the create rec entry, which again calls the retrieve common and then terminates here. Let's look at the time column. So we start at 7 minutes 29 seconds. From here to here, there's a gap of about 7 seconds. And then from here to here, there's a gap of about 7 seconds. So what does this mean? It means that the retrieve common execution took about 7 seconds to complete. And the pattern is again repeated here. So just looking at the timing column, you can quickly isolate that this retrieve common procedure is taking long and is the source of the bottleneck. And therefore, you can start to start your troubleshooting from this procedure. And you can continue adding the this DBMS output put line inside and further continue narrowing and isolating until you finally find that area that is causing the bottleneck. I hope you found this information useful. If you like the content, please hit the like button and subscribe. Thank you.